Okay, so we'll go ahead and kickstart the discussion today. Today we will talk about Apache Pig. This is an API or a ecosystem project which is available or built around the Hadoop framework, which helps you give a easy workflow type of language to write your MapReduce jobs for people those who are not very much into Java or J2E Java based programming. Apache Pig is a good alternative to go ahead. So we'll talk about some of its background, the components that it has, how it works with the MapReduce part, the language which Pig uses, that is the Pig Latin, and then we'll just have some closing discussions. So the purpose with which we go for when we talk about Apache Pig is that we know that MapReduce framework is a very powerful framework and it's a key component of your Hadoop API. But it's just that since it's written entirely in Java, it might not be very much in first attempt understanding to people with a non-Java background. So it requires a Java programming knowledge, and you have to use a lot of these internal capability or the things which we typically already do through some other processing, like joining of the two jobs and filtering of a specific output and all those things. So basically the issue is that it's all in Java. People need more alternatives and all. To that point, your language or Pig comes into for your help, and Pig has the specific language component, the Pig Latin, that is the workflow language which Pig offers you, using which you can interact with the data in your HDFS and write smart workflows, which in turn in the background will be created into a MapReduce if they need to be, and the processing will be done accordingly. You can see that Pig, it provides a higher language, that is the Pig Latin. Very short and abstract. That difference you will start feeling, that you don't have to write that many lines of Pig statements or Pig Latin statements, the one that you will do typically in a Java based stuff. We have seen that how much at least of the effort of the required in terms of creating the project, writing the code, compiling it, packaging it, and then pushing into the MapReduce job. Pig Latin in that sense will be far more easier. Just some numbers that it are given, that how much of a time difference it could be, but again it depends on the type of complexity and all that you are involved with. A very good thing for people with non-Java background into, or the programmers which are not very familiar with the Java part. Many internal or common operations like joining of the two data sets, grouping them on a specific field, filtering it out, as well as sorting it on a specific criteria is off the hand available. If you have to do it in MapReduce, you will have to customize it a lot. Even to change the sorting as well as to do a grouping, you do have to specify or many times do custom implementation. Pig is a more friendlier approach when you have that type of need, and we'll see in a while when we'll do some examples how easy it is to do that. The Pig engine, which comes inbuilt, sits on top of your Hadoop framework, and it tries to take the calls or the commands from the user, interpret it at the Pig execution or engine level, and then submit it to the Hadoop process where it is executed in a MapReduce manner. So this is a level of abstraction above your Hadoop. If you write it in directly in Java, you directly push your jobs into the MapReduce framework, which is inside the Hadoop framework. But if you are writing a pig script, that is what you will be calling it as, you are basically submitting it to the pig engine, which in turn will do the submission to the MapReduce framework. And that's what it says, that since the pig engine sits on top of the Hadoop system, it removes the typical need for the users to tune Hadoop for their needs itself. They don't have to essentially know Hadoop if they don't want to, but they can still write their workflow and expect some parallel execution to happen, or they can expect that that particular capability will be leveraged. You'll see later as you go deep that Pig is a standalone product. It does not need Hadoop if it has. So it's like if you have Hadoop, or if you want to combine it with Hadoop, that is the best combination you will be having. You will be able to leverage Hadoop capability when you use Pig. But Pig also has that is what is called as typically the MapReduce mode. So moving forward, with all these ecosystem projects like Pig, HBase and Hive, you will have a local mode and you also have a MapReduce mode. All these individual products are standalone independent products. So when they are used locally, they don't have their tie-up with Hadoop, and they don't leverage that distributed capability which Hadoop has to offer. And that is in that form, when they are not using Hadoop capabilities, they are called as, or they are said to be in local mode. But when you club them up, or when you want them to leverage Hadoop features in terms of distribution of data as well as the job processing, you will use the MapReduce mode for this one. And we'll see that how to specify whether to be in local mode or MapReduce mode. But those are the distinctions which you will have with these individual ecosystem projects. It's definitely for Pig, for HBase and for Hive, you have these two individual modes. On a discussion as to why you need a new language, we'll be seeing that Pig Latin is a data flow language rather than a procedural or declarative language. So in that sense, it's a more, I'll say, easier approach towards solving the same need. The flexibility that it gives is that your user code, which will be either directly commands which will be using, or your scripts, as well as any libraries or extra files which you want to push in, you can include at any point of time during the execution. You don't have to submit it in the very beginning itself. You'll see the flexibility coming in. You don't have a lot of need for metadata, but you will be using it whenever it will be required. Nested types as well as combination with HDFS and all is also followed. Pig will be mostly like a interpreter type of language. If you guys have earlier any experience to work on it, wherein you write one command at a time and it gives you a result. So it's a individual command by command line. You package all the commands in a file, save it as a script file, and then submit it to Pig to do line by line interpretation. So Pig is kind of an interpreter, wherein you will provide individual lines to execute, and the output of the preceding line will act as a input of the next line in most of the cases. So that's how you build the flow. That's why it is called as a flow language. And we'll see some more details as it comes once you start seeing the artifacts. things will make more sense. It's just that we are trying to understand that this Pig is an alternative to your MapReduce, a more easier way compared to the Java based of doing things. It's a layer which sits on top of your Hadoop. It has its individual mode also, which is typically called as the local mode, when it does not leverages any of the Hadoop capabilities. To have a little bit of background, this is something which came in from Yahoo Labs. Yahoo was the first one to start implementing Hadoop based on the research paper from Google. Pig was discovered there so as to make sure that people who are not much into Java, they should be also effectively able to leverage this capability. My numbers which are given is around 30 to 40% of the jobs at Yahoo runs in this form. Some common business cases wherein you can see Pig to be used: weblog processing, data processing for web search platforms, ad hoc queries across large data sets, as well as rapid prototyping of algorithms for processing large data sets. So it depends. Again, the business cases for Pig is not going to be way different from what we have already seen for Hadoop in general. But yeah, as you will understand Pig, you will see that it's far easier to work with Pig, at least in terms of the capabilities that it supports. And to do rapid prototyping, you don't need a very sophisticated Java developer who understands and then maps it down. Normal people with reasonable analytic skills, they can also write the statements in Pig form and try to leverage the MapReduce capabilities. But the business cases for Pig and Hadoop remains pretty much the same. Anytime when you have a large data need or a large data processing need, actually, you will go for a Pig-based execution. As we talked about, that there are multiple ways by which you will be able to interact with the Pig. Let's call it as a framework. Hadoop we did call because it executes in a process mode, script mode and all, but you have to a Pig installation or a Pig framework, you will be able to either submit a script directly, and each of the scripts will have individual command lines to execute, or you will use a most common shell that it has, that is the grunt shell. That is a command line type of interpreter, the way you have the command line or your terminal wherein you type line by line and it gives you the result. Same way is your grunt shell, which will get open inside your bash or con, whatever the shell that you are using in. Yes, if you are very much addicted to Java and you want to even use Pig through Java, though not much of a sense, but many times you just want that capability, that you want to leverage the best of the both. You still have Java guys, but you don't want to write a very complicated implementation in Java. So you might as well write your Pig related commands or Pig related logic in Java format, and that is something which is feasible using the Pig server Java API. Then you push it to the Pig framework to execute it on your behalf. Other things, again, there are a lot of open source works which keeps happening around Pig. A lot of plugins have come in, as well as reusable code. PigPen is an Eclipse plugin which you can just add it as part of your Eclipse API, the one that we have used for our previous developments on Java, and it can give you some more featured availability. So these are the 4 different modes in which you will be normally able to access a Pig framework. The execution mode we have already talked about. 2 execution modes. One is your local mode, when you are not using Hadoop cluster, you are simply using the core Pig and its own capabilities. But when you want Hadoop also to be used for distributed capability needs. You push Hadoop or you open Pig in a MapReduce mode. This is the high level architecture of how these components fit in well. So you can see that Pig will reside in your local machine, that is user's machine, and your jobs gets executed in the Hadoop cluster, which is, I'll say, the virtual cluster which is available there. And the best part with Pig comes is that you don't need to install anything extra on your Hadoop cluster. So it's not that suppose you have 100 systems, on each of them you are going ahead and installing Pig. You don't need to do that. The only place where your Pig needs to be installed is the client or the user where you are writing the Pig scripts, so as to compile them and push it into the Hadoop cluster. If you don't want to use the Hadoop cluster, that also is good. You can just run it in a local mode. So out of all those 100 nodes, any one of them can be a place wherein you can install Pig, write your scripts, and then once needed and verified, you can push it into a Hadoop cluster. Now that happens automatically behind the scene. You have to open or you have to use Pig in a MapReduce mode, which means that now everything which you will be doing in Pig will be pushed for execution into a cluster. If you open it in a local mode, it will always be done locally on that same box. Take a good look at it. This is how a typical Pig statement will look like. The capabilities of Pig, the installation is exactly similar to the way you have it for Hadoop. We will follow that, like downloading the tar file, untarring it, setting the variables, and then opening the Pig in the form which we want to execute it, whether local or MapReduce. So assuming that, and again, Pig files are available as jar files, in the sense that Pig is also written in Java, but it gives the people the ability to just write it in a workflow language. So Pig is written in Java. It requires your other Java home and all that to be set. So that's something which assumes that you already have an Hadoop presence. But if you don't have any Hadoop installation done and you want to just play around with Pig in the local mode, make sure that Java is available, because Pig will require that. But typically it's done that first you already have a Hadoop thing wherein you have already taken care of the Java part, and then you add or install Pig on top of that. Assuming that you have the minimum basic requirements and you are able to open the Pig grunt shell, this is how you will typically write Pig statements. You can see that you do basically an assignment type of interpretation. Pig Latin on the left hand side, you will see A equal to load my file as XYZ. This is something which will load my file, which is available in your local directory, and it expects 3 parameters separated by default it is tab. So XYZ are the 3 datas which it will fetch in. You can then filter it using a specific criteria, that out of all the data that you have loaded, filter that data on a specific criteria, then you group by on specific criteria, then you loop around, that is your for each operator, and you can, when you are looping around or going through a for loop, you can count also, and then you can finally dump the output in a output file, which you can then open through your name node, or you can browse it through your name node visual mode, or you can use the direct DFS shell to go and browse the same. If you are using pig in your MapReduce mode, even in local mode, you can just go to that file and access it. But at least at high level, you should start getting a feel that pig in this case is very much intuitive. The way you typically do, or the way you will in first hand write your pseudocode, same way pig tries to write the jobs. Internally, when you submit this type of pig Latin statements to your pig framework, it will first parse the file, check for any errors, do any optimization which it can. It will do the execution plan for you depending upon the complexity that you have done. You can see that it then plans out that depending upon what all you want to do, it plans out how to split it into different map tasks to parallelly do that, as well as also reduce tasks at individual level, so that all complexity goes down, wherein you are deciding what goes in map, what goes in reduce, and all this input, output, and all those things. The plan is developed by pig depending upon the statements that you have written, and that is a more optimized plan. Then it submits it to your Hadoop process to execute the same, and once the result comes, it will show you the job, or it will show you the data in wherever form, either MapReduce directory or in the local directory. So this is a sample pig related things: loading of a file, filtering it by criteria, grouping it by a specific attribute, and then looping around. These are just some operators. We'll go later on into more details, but at least you should start getting a high level feel that this is what you can expect in terms of the capabilities which Hadoop will be, which pig will be specifying in. Now, a common question that will definitely arise when you have these type of alternatives, that how fast it is, or why should we move to pig, or does it has any performance impact and all. These are some core numbers which are put in by the Apache Pig team, just to give you a high level idea. Try to visit these sites and get some information about that, under what situations, or at least what is the level of factor of advantage that you are getting in. Good amount of details are available on Apache Pig site to do that comparison. Now we'll come into the low level details of the pig Latin language and how it goes into those individual details. Okay, so let's continue going more deep into the pig Latin language constructs. We have these individual data types. Now pig Latin also is a language, so some common things to expect is the data types and some of the internal attributes that it will offer. The data types which pig Latin supports is your integer, long, double, character array, as well as byte array. Some individual, so these are your scalar types or primitive types which are supported. Some other complex type in which it can read data as well as store data is your map, tuple, and bag. Now map is basically a representation of your associative array, arrays which are related to each other in terms of the data which they are storing in. Tuple, we'll see later excuse me, will be ordered list of data. Elements may be of any scalar or complex type. So in a tuple you can have a map or an ordered list of map, or you will have, if you have just a scalar quantity, you will have an ordered list of integer or an ordered list of long or double. Bag is an unordered collection of tuples. So you can see that one input or one type becomes a subset, and also map is inside your map. You will have many scalar types. Inside a tuple you can have scalar types as well as maps. Inside bag you can have tuples, which in turn might be containing map or scalar type. So it goes like one is a subset of another, and that associative level of details keeps going on that particular part. So it's a nested data typing that is there in Pig Latin, which it supports. So map, tuple, and bag is the key API. And this is some example which it has followed in Cloudera Forks and all, but this is, we'll use it a more specific thing. All I wanted you guys to see is this is the grunt shell. This is how it will come in once you install, and this is the way you will specify whether you want to use your pig in local mode or MapReduce mode. So using the -x operator, you type local, it will open it in a local mode wherein it will not leverage any Hadoop capability, and it will, if everything is successfully installed, it will just show you the grunt shell directly. If you don't write anything, if you just write pig, the default behavior is to go into a MapReduce mode. It will always in that case open MapReduce mode. So for local mode you will have to explicitly write it. You can go to MapReduce mode by using pig space -x space MapReduce. You can type it, then also you go. If you don't mention anything, default is MapReduce. For local, this is how you'll be typing in the detail, and grunt shell is what will come in. This is how you'll do a simple aggregation of data which you want to load through a pig shell. On the grunt shell, you will start writing something like log space equal to load, specify the name of the file as, and then you specify what you want to load depending upon the tab separated things which are coming in individual lines. So by default it is a line and the separator is a tab. So it expects 3 fields in one line, in this case user, timestamp, and query, separated by a tab, and accordingly it will load that. Once it loads, and this is all in memory, it will load. After that you can do a group by your user. It will automatically change those individual tuples. That is how it will be taking it. So each of those user, timestamp, and query will be loaded as tuples, and those tuples will again be then grouped as based on the user. If you see this behavior, it is very close to your SQL, at least in some sense, but not exactly the same. Like it's a kind of mix of your PL SQL type of thing or stored procedure, wherein you use some sort of programming behavior or procedural approach in terms of loops and all, as well as you also use your SQL approach, in this case like group by or loading the statement. So if you are familiar with either of these, or at least have written one PL SQL job, this will look in that sense very similar to that. And it's also more interactive. You understand that line by line how things are happening. You are loading first, grouping next, then for each group ID which you have stored, you will generate a group and the count of the individual logs. So this is the aggregation that it will do. After that you will store it in an output file. When you open the output file, you can expect excuse me, the result to be there. Now behind the scene, this whole thing, since you open it in a local mode, in this case it will not use any Hadoop cluster distribution. It will do all these in the local process or OS itself, and that is where you will see that it will take more time. If you have a cluster, it will distribute the same thing, the grouping part as well as the count part, it will distribute the same. If you have a Hadoop cluster, get it done fast and then continue with each of the for loop that it is coming in. So this is a simple Pig Latin script to read a file, do a simple grouping, and have a traversal around it to do the count and put it, output it there. So where it will try to now go and take a look at individual things, what's happening on each of the things in terms of the command level. So data sets and aliases, that's where you'll see things coming. So as I say that each statement delivers a new data set, possibly in terms of existing data sets. So when you load the log file using the load statement, each line will be read as a data set. The important thing to note is that each data set is immutable. So once read, you can't change that, and that's a good thing because it just avoids changing, or in a multi-threaded processor environment. It will make sure that one data set is worked and it does not change your raw data. Now in this case, you are using that whatever the load is loading, that data set, you are giving it as an alias name. Log is here the alias thing to refer to that data set. You don't have to write a long reference type that it is an array or it is a list and things like that. You simply use log, which is a pointer to the overall data set which your load statement has given, depending upon how it has loaded the, in this case, the log file. As you say that load statement, it returns a bag of tuples. See that a bag is an ordered set of value. Each tuple has multiple elements which can be positionally referenced or by name. So this one, you can see user, timestamp and query. You can refer later on by name, or you can also use $0, $1, $2. Very common syntax which we used in Linux based type of system. So we'll see it in some of our exercises using both to just have a play around with that one. But at least when you are into Pig Latin, at least some of these common terms will start making sense to you. Tuples, bag, maps, and how you load your data set as well as do advanced operations on them. Bags and for each, as it says that the for each generates statements, it iterates over the member of a bag. That is your for each statement that is there. Now when you go for each, or like each iteration will create another bag, and that's where you will be finding the individual elements. So as we talked about initially, your map, tuple and bag, they are nested data types, so they will be stored one in the other form itself. So in that sense, again, it might be a bit consuming, or it might take some time initially to understand the internal storage. Even if you don't, that is still okay, because as long as you understand that each of the data is getting loaded as a tuple and internally it is then stored in a bag to refer it or to send it to the next level of processing, that should be good. These are some internal things to know as to how Pig Latin is actually trying to store that data. All of this approach will change when you look for some other alternatives like Hive. So depending upon your interest as to how much you really want to learn this, you need to focus around that part and refer to the documentation. And this purpose of the course is to introduce you, make a basic set of introductory knowledge, the installation to be done, so that you have everything ready to go ahead and go deep into Pig and all. But Pig is just an alternative. Positional references, as we talked about, either you refer them by name or by individual references, $1, $0, which will refer to the individual fields. That's what it is doing. And as I mentioned, that this is something which will be very similar to your PL SQL type of things, wherein you have the capability to loop around, as well as you also have the SQL-like capability to group by or load and all those things. So very much similar in that syntax, mostly as a workflow type of language is what you are putting in. First you will load the data. If you want to group, you will do that. If you want to iterate, that also can be done. All the number conversions, all these things which you might be coming, that if there is a number and all of that is available. If you refer to PIC documentation, almost all the primitive data types are supported. Custom data types or user defined data types, typically the complex data types, are represented in the form of your bag, map and tuple. That is where the representation will be done. You can see here that you can have the individual grouping thing also. Excuse me. So you will explicitly call a group function if you want to do individual group by, very similar to your SQL group by on a specific field. It will then, the key and the bag pairs which are stored as a tuple, all of them will be grouped based on the key that you provide. So the internal representation is like that. You can see a specific group by statement here. If you have these three record items like Alan space 1, Bob space 9, Alan slash 3, and if you load it first in your PIC command and then you group by the name or the user first name, this is how the individual tuples that will become. That's where it says grouping and types. Specify some more low level details, specify the group by, specify the key. You can go into more complex implementations of that when you use bag of in and out. This is something I'll request you guys to explore more. At least the purpose here is to show that the capability is definitely there. You have to have more deeper level of understanding, at least from the APIs, to use those advanced features. But the basic loading, grouping for each, storing it and dumping the data on the output is something which will anyway practice. These are some capabilities which are close enough in syntax to your SQL. The other important command is filtering, which is very similar to your where clause in SQL, that you definitely many times want to filter a specific type of data. So continuing with the same example that it gave, the log file, you grouped it by individual user. You have now the count also for each of the log, and now you want to make sure that on the users which have only more than 50 log counts, which shows that some substantial activity was done, they only need to be stored as an output. So you will store them only. You don't want to, like in this case, you have this criteria that don't store users which have just 5 log counts, because that shows that they might not have been there on the site, or in terms of their usage they're definitely not very much. So that is where you can use the filter command. So load command, group command, for each command, your functions like count, you have like count is there, you have max, min, average, sum, all of that is available, all what you see in a SQL level. Filter by is very much equivalent to your where clause. Store is typically used to write the data into a specific output file. This is the ordering thing. You want to sort it by a specific value. Now that value could be your primitive value like user name, user time and query, as well as it can also be the one that you generated through one of your I'll say aggregated operators like count. So herein you could have done it by individual user time and query, or you could, what you are doing right now, it is as a count level. Order is similar to the order by statement that you have in SQL. Now going more level of details, this is just an example of how you will summarize or pretty much write the word count type of program when you go for more I'll say complex implementations using the joins and all other parts. Excuse me. This is something which we'll see also directly. That is something which we'll be seeing in when we do our exercises. One another important thing, at least in Pig, is this flattening sets. That is an important thing to know. We'll quite often do that flattening when you are running it as a map reduce part. You can see that you will use the tokenize operator to read a line and give you individual tokens, a typical requirement that you have in the map reduce in the word count program, that you want to read a line and you want each word to be given rather than the whole line. Use tokenize, it will automatically tokenize based on the tab related thing, and then you use the flatten operator to separate the same thing. We'll see an example of flatten later, but flatten is something which will elongate your data set which has come in. It gives an example here that if A was something like string, after tokenize it will become individual, something like this. Individual grouping it would have done. So this is something like, you can understand, this is Hadoop training, something like this, and these are the individual counts that it has made. When you flatten it for each one, it will get state. Later on we'll do it more at an exercise level to get more detail, but yeah, remember, tokenize, it's like a tokenizer which gives individual words. Flatten just expands the individual tuples which are coming in. Again, more complex operations like join and all can be available, wherein you can just load two different inputs. You can say that it is loading Shakespeare's book as well as Bible, and then it is joining both of them individually by word, and then it's trying to do an output thing. Again, similar to what you will do in SQL as a join, which is basically a Cartesian product of the two files. Herein, instead of having a RDBMS table, you are having individual set of or a bag of tuples which your individual load statements have loaded. Then you can combine those inputs at runtime and then give a direct result. You can see that if you want to find all the words which are in the Bible copy but not in Shakespeare, you go for a anti-join type of pattern. Very similar to in SQL, not in operator. Go into two data sets, first you join them and then you filter by what is not available. That's what is called here as anti-join. Co-grouping is another capability which it says that you'll have this thing wherein it is collecting the data from two different outputs, two different load statements giving you the data, and then you collecting the same and then applying the operation based on your criterias. This is just some further details around the same co-grouping, that if you have this is as input 1, this is as input 2, so this one loaded by first load statement, this is by second load statement. This is how it will be when you club it together. As we talked about, that by default Pig treats data as untyped, so if you don't mention it, it will always take it as untyped, in the sense that character string or string is what it will take in the data. But if you want to specifically specify that in my file the first thing is an integer and the second is a string, that is how you should load. You have to specify it like this, wherein you're specifying that the first letter in that frequency underscore frequency file is an integer, the second one is a character array or a string. So you are specifying to change the data type. By default all of them will be taken as string, or basically character array. This is where it is putting the particular thing. You can see Pig is also smart enough that if you haven't specified type, but if you try to do an operation like multiplication, it will automatically typecast this thing into a equivalent value and then multiply it, because it knows that 100 is an integer with that multiplication operator. So it will automatically typecast frequency into what is the type for 100 and then give you the result. So in that sense it is smart. Again, you have different types of other loaders which are available, which can load the data from specific type of other features or data sets which are available. As you can see that by default Pig will assume the data is tab separated and in UTF-8 format. You will be able to specify your own delimiter. This is something we'll practice later on. We'll specify our own delimiter when we are doing the word count program, because at that time our delimiter will be a line instead of a tab. That's what the individual thing which you want to read. That is very useful when you load data in different formats these days, like JSON and all, as well as many times you read even XML, and also you'll have to have a different way to read the file and specify your own criteria. Pig has this Pig JSON loader to load JSON type. Pig storage is another generic type of loader which is available, wherein you can specify the delimiter and it will accordingly load that data for you. Important thing to note here is that Pig has written a good amount of functions usability thing for you, but there is always a possibility that some of the thing which you want to do more at a low level programming might not be available in Pig. Pig is just an abstraction. Behind the scene it is also creating those individual parts. So for things like that, Pig gives you the ability to write your own user defined functions. You write that part and you can leverage it the particular file itself. So you can see here so for nesting also can be added up. That's something which is available to PL/SQL language level. The same will be available here also. Just have to order or nest it in the right manner. Capability wise it's supported. You see that things like split and all others are available. These are some advanced features which are very I'll say individual business or use case specific, wherein you don't want to have the data flow in a linear manner. You want to load it into different specific like in this case, if you see that you are now grouping first by 0, 1 and then by so $0 is your first parameter in the data set, $1 is your second parameter. You want to do the parameterizing on different parameters at different places or at different point in your workflow. You can do the same, and then you can So accordingly you can load the data as well. To do the same, this is a high level list of the commands which your pig supports: load, store, for each, filter, some common things. As I mentioned, if you have to go and take the low level details of each of it, the best documentation is Hadoop pig documentation, Apache pig documentation. Pig is gaining ground. It's definitely a big thing, or have favorite at Yahoo, but other organizations are also embracing the same as a alternative choice. If you are not something which if this is something like which you have not been, if you are not into Java, neither any of your streaming things like your C hash, if you are a Microsoft platform, or your Python if it's an open source, or Ruby, if those alternatives are also not available, and you want to really go for something at a workflow language which is agnostic of any of these programming language architecture, Pig offers you a good platform. The Hive, another part, is more friendlier towards the database folks. But Pig is kind of a mix between your SQL as well as also your uh, normal iterative processing and loop type of behavior. So it's a good combination to be used in. So these are some high level commands. Refer to some Apache documentation for more lower level and commands as well as examples. This is where we close our discussion on the pig aspect. Thank you for the discussion on this particular pig topic.